Hello friends, welcome back to the tetrahedron chemistry classes. So guys, in today's class I am going to discuss a very important drug, and the generic name for the drug is the metamizole, and sometimes it is also known as the DIPYRONE. Apart from these generic names, brand names are also there for this particular medicine. This Novalgin is very much famous in India, and then your Analgin, which is another trade name, it is famous in the Russia. And then you can see your algocalmin, crospyrone and K-nalgin. These are the other trade names, and the commercial production of this particular drug has started in the Germany way back in 1922. But after that there is a problem actually with this drug. It causes actually agranulocytosis, right, which is the problem for this particular drug, and this is actually the medical term. I am not very familiar with these medical terms, right, and I'm not very comfortable in pronouncing these particular terms actually, right. But you can see if you are a pharmacy student, then it would be very common for you, yeah, right. Agranulocytosis, basically it is the type of the disease in which the white blood cells, actually the granulocytes actually decreases very rapidly in the white blood cell. It's a very serious disorder, and these disorders may be due to the some diseases like autoimmune diseases causes this particular problem. But the consumption of this particular drug metamizole also causes this particular problem. It's also banned in India, and then the ban on this particular drug has been lifted. Now it is available in the Indian market also. How actually it acts actually, what is the action of this particular drug? It is analgesic, and sometimes it is also antipyretic. So basically it has two actions. Main action is the analgesic, and other action is the antipyretic. And in my previous classes I already told you the drugs which actually reduces the pains are called the analgesic drugs, and the drugs which actually reduces the fever, they are the antipyretic drugs. So basically when the pain started after the surgery, then this drug is very common, right, metamizole. And sometimes pain in the gastrointestinal tract, when a person is having the pain in the GI tract, gastrointestinal tract, then this actually painkiller is frequently used actually, right. And then sometimes if a person is having the migraine problem, migraine is very common now these days. And in this kind of the headache which actually comes due to the migraine, okay, this metamizole has been given. But see, these are the actions, but it is also having the side effects. So rare but very serious side effects you should know for this particular drug, right. This is something very important. This is your anaphylaxis. This is very important side effect. However, it is very rare. Only unlucky person actually, right, can have this kind of the side effect, but this side effect is very life-threatening side effect, right. So if any person is suffering from this particular side effect, anaphylaxis, say the person may have the itchy skin, right, and sometimes the skin rash can also be there, and eyes, lips, right, there will be a significant swelling in the lips and the mouth actually, especially, right. And person can feel very restless eyes, that burning sensation in the eyes also, similarly burning sensation in the feet and the heads, right. These are the side effects, okay. And swelling of the mouth, swelling of the throat area, okay, then breathing difficulty, right. Lots of problems are there, and it can take the life of any person, right, if this side effect occurs, but it is very rare actually, right. And then second one is the blood disorder, another very rare kind of the side effect, but it is rare, but it is actually the kind of the blood disorder, and which can again take the life of the person. And then there occurs the Stevens-Johnson effect. It is again the kind of the skin disorders actually, and again these are the very important ones. So these three are the rare but the serious side effects for the this may come after the consumption of this particular drug. And then there are the very common side effects which anyone can feel actually: low blood pressure, chest pain, then arrhythmias. It is a kind of a heart problem, right. irregular heartbeat, you can say. Okay, then nausea, person may feel like sickness, and say it may feel to vomit actually. And then upset stomach is another problem. Dizziness, that means you are not advised to drive, right? So your judgment would be not very good if the side effect occurs. And it is kidney toxic. Please remember, it is kidney toxic. And shortness of the breath is also there after the consumption of this particular drug. But see, these side effects actually depends on the person to person, anatomy of the person to person. Okay, so, this may come for a particular person, this may not come for the particular type of the person. So these are the different little things which you need to know. Now the very important part, the chemistry part of this particular drug, how we can synthesize this drug in the lab, and the reaction is very important. And you have to focus on the reactions actually, right? Because you will not find the detail of the reaction mechanism in any textbook, right? Not easily actually. It may be present in certain textbook, but it is not actually readily available in the various textbooks. So what you can do, you can focus how we can actually synthesize this particular drug in the lab. Okay, so I'm taking this starting material for this particular drug. Say this is my 5-member ring, this is my oxygen, this is double bond. Okay, and then one nitrogen is there and another nitrogen is there, right? And it is having the substitution of the methyl group, and this is also having the substitution of the methyl group, and then you are having the NH2 group. Okay, your amine group is there, and here you are having your benzene ring, that is C6H5. I am writing phenyl as the, just like that actually. And you can start this reaction by condensing this particular compound with the say your benzaldehyde. Okay, say this is your benzene ring, right? And this is your carbon, this is double bond oxygen, and this is your hydrogen. So basically it's a kind of the condensation reaction. You are condensing the two molecules, and in the condensation reaction, you know, the important feature is that a small molecule, two molecule will fuse and one small molecule will eliminate, right? So you will eliminate water molecule from here, and then you will fuse this remaining ring into the system which is actually given in the intermediate 1. So I can write it as intermediate 1. There is no need to learn or to mark the IUPAC name or the name of this particular intermediate. You can simply write this as the intermediate 1. So you are having this particular species. Now what you will have after this reaction, right? So this is your say C6H5, okay, and then your CH, double bond nitrogen. Okay, there is no problem in that. And then this is connected with this system, which is double bond here, nitrogen is here, and then you can write another nitrogen here, methyl substitution is here, and another methyl substitution is here, and already this system is having C6H5, right? So what you have done only, you have only fused this particular system onto this particular nitrogen atom after the removal of the water molecule. So in this intermediate 2, so I can write this as intermediate 2. What I have done in this intermediate 2, basically I have written this phenyl ring as C6H5, and this is the CH which is remaining just like that, and this is the double bond here, and this double bond is connected with this nitrogen, and then the remaining part of the system. Okay, this is something very important which you should know. And after that, what we can do with this second reactive intermediate, or second intermediate, not reactive intermediate, very sorry, with this second intermediate we can do the methylation. Basically alkylation we will do here, so I am writing methylation here. I am doing methylation, and very famous methylation is here Me2SO4. Okay, so I can write it here as Me2SO4. I can write this Me2SO4 like that. Basically it is dimethyl sulfate. Okay, so how the reaction goes? So for this particular reaction, you need to understand what is the structure of actually this Me2SO4. This is something very, very important, right? So how we can write the structure? I am writing the structure here. Say this is my sulfur, this is double bond oxygen, this is double bond oxygen here, and then I am having my O and CH3, and then again I am having my O and CH3, right? So this is the structure of your dimethyl sulfate, and this dimethyl sulfate is frequently used for the methylation of amines, phenols, or the your thiols. So in that case you are having the amine here, right? And don't forget to put the lone pair onto this particular nitrogen atom. Okay. So what we'll do the methylation onto this particular nitrogen atom. That means one of the methyl group, either this one or this one, you can use any one. This may actually go to the nitrogen atom. This is something very, very important. So how it will go actually, this actually the lone pair which is present here, this will grab one of the methyl from here, and it will push back the electron pair onto this particular oxygen atom. Okay, and what you will get after that, I can write it here. So this system you are already having C6H5 CH double bond, okay, and then this is your nitrogen, and now this nitrogen is having the methyl group. Why? Because this nitrogen actually grabbed this particular methyl group. Okay, so this is something like that you can write. Okay, and then the remaining things are actually the same. There is no change in the remaining thing, right? This is your 5-membered ring. Okay, this is your double bond oxygen. Put your nitrogen here and put another nitrogen here. This is methyl substituted. This is also methyl substituted. The important thing is that this nitrogen will have now a positive charge. Because why this positive charge is here? Because the electron pair which is the property of the nitrogen atom actually has been used in the formation of the bond with this methyl. So automatically, basically it's a quaternary salt, right? It's a kind of the salt actually, which is see, this thing is very, very important, and this reaction basically goes through the SN2 mechanism. Please remember, this reaction goes through the SN2 reaction mechanism. Okay, this follows the SN2 pathway, and since this positive charge is there, it may be present as the salt. Then your counter ion actually, in that case I can write in that like that, CH3 O SO3 negative. Basically this is the entire system. This is your entire system. So you can see here CH3 like that, O like that, S 1 2 3, that means 3O SO3 negative. So this is the salt, and basically it's a quaternary ammonium kind of the salt. And after that, what we can do, we can hydrolyze this particular salt, right? And once you hydrolyze this particular salt, then you will get another intermediate. So how actually the hydrolysis will take place, we can see here like that. So guys, for hydrolysis actually you may take this H positive in the acidic medium, okay, and then you can take your water. So basically it is kind of the acidic hydrolysis. Please remember, it is kind of the acidic hydrolysis, because see, I need some space. So what I am doing, I am removing this part. Okay, I don't need this part, so I am removing it. And then what will happen after that, you see here, this H positive actually, right, this H positive will go to this particular nitrogen atom. So how it will go actually, you can see here, this will shift here, okay, and that electron pair will grab this particular proton, and you will have this intermediate now, C6H5 CH single bond nitrogen. CH3 was already there onto this particular nitrogen atom. Hydrogen it has grabbed from this acidic environment, and then your remaining part is same. Okay, this is your nitrogen, and this is your nitrogen again. This is substituted, methyl substituted. This is also methyl substituted. Okay, now you can see here, this nitrogen actually is now electron deficient. This particular carbon is now electron deficient, and what you can do, you can put a positive charge over there. Okay, and this nitrogen was actually already deficient. Okay, this was already deficient, so 2 positive. See, however, it is not correct to put the 2 positive charge onto these on the 2 neighboring atoms. One is carbon here and another one is nitrogen, but this is only for the sake of understanding, how you can understand the things. But this will this will happen in the one single step, this hydrolysis. So after that, what will happen, actually, you have taken this H positive has been grabbed from here, and what you left with in the system is what? OH negative, right? This OH negative is left. So this OH negative will attack onto this carbon atom, right? So basically, earlier you have formed this particular ion, which is when double bond is here, it is the iminium kind of the ion. Okay, but then your OH will attack onto this particular carbon atom, and you will have this particular intermediate. I am writing in the next page what you can have. Then you can have C6H5 was already there. This was your CH, and this was your nitrogen along with CH3. Okay, hydrogen was already there, and this was having the positive charge, and this has now OH negative. Okay, and there is no change in this particular system, so you can write nitrogen here and your another nitrogen, and these two were substituted with the methyl group. Okay, I think there is no problem in that. Okay, and then what will happen, actually, in the next step, since you have your hydrolysis system, so say this is your H2O, which is already present in the solution, actually. So what I can do, I can remove this and I can put hydrogen in the bond form, right? I have put this bond here. So what can happen in the next step, basically? So this actually H2O, which is present here, will grab this hydrogen, okay, and this double bond will come here, okay, and this bond will get broken and goes on to the nitrogen atom. So what you have done in that case, you have removed C6H5 C double bond OH. How you have removed? See, this is C6H5, which I have written here. This is now is doubly bonded, so carbon double bond oxygen, hydrogen was already present here, okay, and this bond will get broken now, right, just like that, and this hydrogen has been removed from here. So you have removed this and H3O positive. Basically, it's a very famous reaction, that is the synthesis of your aldehyde and the ketone with the help of the amine. Very famous reaction, please remember. Okay, now what you left with then? So you left with this, for this species, oxygen, then your nitrogen, and then your nitrogen again here. This is methyl substituted, this is also methyl substituted, guys, and then you are having NH, CH3, and this one was already having C6H5 there earlier, and this one is also having C6H5. Maybe in the previous slides I have missed this C6H5. Yes, you can write C6H5 here, okay, just like that, and then you left with this particular system. Now it's very easy to form your product, actually, which is your Novalgin or Metamizole. How you can form the Metamizole? For this, you will take this system, okay, your sodium bisulfite NaHSO3 along with your formaldehyde, right? You will take this thing. So how actually these two reacts? You should know the basic chemistry, actually. Reaction of the sodium bisulfite with the aldehyde and the ketone, right? This is H, C double bond O, and this is H. This is your formaldehyde, guys. Okay, so how the reaction goes? This will come up and this will grab sodium from here, Okay, not sodium, very sorry, I made a mistake, because hydrogen is already present there. Okay, acidic hydrogen is actually present here. So this will grab your hydrogen. Okay, so what product actually it will form? You can write like that: carbon in the center and two of the hydrogens. Okay, this is the carbon, these are the two hydrogens which I have written over there. Okay, and now this, you see, single bond oxygen, just like that, and it will have your H, OH, and then remaining part is your SO3Na. Okay, so this will form this particular intermediate. Only if you understand the formation of this particular compound, which is a very famous reaction in the class 12th actually, only then you will be able to form the final product. Otherwise you will find very difficult to form the product actually. Okay, so what I can do in that case, I can remove actually these two things which I have actually shown you here actually, and instead of writing all the things, I am writing just like that. These two hydrogens, this is my OH and this is my SO3Na. Okay, now what actually you will have your final product after the, basically what we will do, this OH negative will grab this hydrogen here and we will eliminate the water molecule here, and the entire system will join with this nitrogen atom. See, because this oxygen is very electronegative, right, when compared to the carbon, when the reaction actually happens, so this part will go with this electron pair and this will come as the H positive. That means electron pair to form the bond is already there onto this nitrogen atom, and you will remove water molecule from here, and what you left with this one, right, what you left with this one, this is your nitrogen. Okay, there is no problem in that with this particular nitrogen. Okay, and this is now substituted with the methyl group, and this is your system. Nitrogen is here and another nitrogen is here. This is methyl substituted, this is also methyl substituted. Now this is connected with the CH2. Okay, and this carbon is already having what? SO3Na. So basically this particular product which you have formed in the last step is your drug, which is your metamizole. This is your metamizole. Metamizole. So this is how actually you can synthesize, or you can understand the reaction which leads to the synthesis of this particular drug, which is something very important, and you will not find easily this much of mechanistic explanation in the textbook actually, right? So this is how you can actually you can synthesize this particular compound. Okay, so this is something very important. So this question may be very important for the students actually which are going for the GPAT examination, pharma students, and it is also there in the BTech first year curriculum. So it is equally important for the BTech first year student also. I hope you actually understood the mechanism completely, right? If you understood the mechanism completely, please write in the comment box, and also you can demand the drug molecules which you want to need to know, for which you want to need to know the synthesis, right? I'll try to make the synthesis of the drugs also, because see, the synthesis of the drugs, the reaction mechanism on the drug synthesis is not actually my forte. Okay, but if you want, then I can upload more videos on the synthesis of the drugs also. For this you can write in the comment section. So that's it for today. Thanks for watching. Thank you very much.